So, welcome to our presentation, Discovering OpenNebula Integration in Product-Ready Self-Clusters. Um, Let me first introduce our speakers. We have Stefan Kooman from BIT.NL Data Centers and Eduardo Fiat from University of Zaragoza. They are OpenNebula customers running CEPH as their main storage backend, and they will share with us their experience in their particular projects and also operational recommendations and suggestions in data center and HCI environments. So if you don't mind, I would like to share with you some self-storage technology background. As you know, CEPH is one of the recommended storage backends for OpenNebula because of its resiliency. It has no points of failure, and because of its scalability. The more nodes do you add, the higher performance you achieve. It requires a minimum infrastructure to run, or an even amount of monitor nodes with a minimum of 3, and always these hosts with a minimum amount of disks and capacity to assure data replication and resiliency, typically 3 OSD hosts. As you know, it can be deployed using dedicated hardware, usually in data center deployments, or it can be deployed using dedicated hardware and shared hardware with for hyperconvergent configuration, and this configuration is typically used in cloud-edge environments. So additionally, OpenNebula can interface with multiple subclusters and pools using a very simple configuration, and can provide key features for cloud operation like theme provisioning, snapshot, clone, compression, encryption. All these features enables OpenNebula as a production-ready virtualization environment and cloud orchestration software. And as we will see in the next one, we will try to explain how OpenNebula interface with CEPH. OpenNebula operation is self-contained, so there is no need of a shared file system for OpenNebula VMs coordination. So as long as you have a CEPH cluster running, there is no other shared storage you need to make your OpenNebula instance to operate your cloud environment. The CEPH Data Store driver allows you to use a CEPH storage for image and system data stores, and it has 2 operational modes, CEPH native mode and CEPH SSH mode. In native mode, the persistent images will be stored in image store, and non-persistent images will be clones of the snapshots of the disk images. In CEPH SSH mode, the images are exported and retrieved from the CEPH image pool to the local file system of the hypervisor. So everything will be run locally and will be stored in CEPH cluster during, let's say, the virtual operation, the virtual machine is powered off. Additionally, CEPH cluster, the CEPH snapshot lifecycle is fully supported only in native mode, of course, and they are used by OpenNebula built-in backup solution. As you know, OpenNebula offers an internal backup solution and relies on CEPH snapshots to run and to operate and to create all the backup cycles on virtual machines. The data consistency of the disk snapshot is assured by using QEMU agent. So this the consistency of the data running in memory in the virtual machine will be consolidated using the QEMU agent, and it's triggered by hooks in OpenNebula as a way to assure the data consistency of the snapshot and to run the backup operation afterwards. So let's go with our speakers. Let me introduce Eduardo Fiat from the University of Zaragoza.
Hello, I'm Eduardo Fiat from University of Zaragoza. I will talk about Project Boira. In some regions of Spain, we call Boira a small cloud close to the ground that can create fog or mist. This is Boira, a modest collaborative cloud with its feet firmly on the ground. We don't seek to compete with other commercial solutions. We just want to learn as we will the cloud. And of course, have a fault-tolerant distributed infrastructure to deploy our virtual machines. We have learned a lot during the implementation of this proof of concept. Boira was created in the framework of Unidigital projects. Unidigital seek, among other goals, to generate solutions that can be of general interest to university system. One of the proposed ways to achieve these objectives is through collaborative projects within several universities. Boira was proposed by University of Zaragoza at the end of 2021. University of Almería and University of País Vasco joined the project in March of 2022. We looked for collaboration of Rediris, who supported the project. Here are some milestones of the project. The signing of agreements was on spring of 2022. Architecture technical solution selections of hard summer 2022. Hardware purchase autumn 2022 to spring 2023. This was hard. Contract for the development service subscription training. This was spring 2023. Implementation release spring 2024. This was planned for autumn 2023. Project requirements. Some requirements were imposed by Unidigital, like the preference for free software. Others were caused by previous negative experience, such as black boxes or vendor locking. We aimed to use mature, standard, and well-supported tools like IBM for virtualization and CEPH for storage. For budget reasons, we opted for an hyperconvergent solution. Why CEPH? CEPH is a free and open source software-defined storage platform that provides object storage. Over this layer of object storage, CEPH can provide block and file system. CEPH allows us to create data pools totally adapted to our needs. We can create a pool with massive spinning disk for backup. We can create pools with NVMe disks for virtual machines. And we can mix a spinning disk with NVMe as well DB that works as cache. CEPH supports different storage policies. We can have replicated pools and source-coded. Data can be compressed and deduplicated. Finally, CEPH allows us to choose the domain failure according to the sensibility of the data, from disk, server, rack, room, region. Is very, very flexible. Why OpenNebula? We decided to use KVM as hypervisor. OpenNebula is an excellent front-end for KVM, and the integration with CEPH is excellent. We also have experience with OpenNebula with good results. We found the flexibility of software very interesting. We had never tried to deploy this kind of solution in our universities before. So we need as much flexibility as possible to be able to deal with problems during deployment. Finally, we contacted OpenNebula to explain our project, and they immediately supported us. And now the network. Rediris provides a layer 2 connectivity with insights at 10 GB. Rediris has deployed 3 VLANs to each of our data centers, one for IBNI, remote shell, and administration interfaces, a second VLAN for shared storage, and the third VLAN for virtual machines of the shared cluster. This is the technology used by Redis to link our clusters, data packets with routing instructions in the packet itself. The clusters. Each university has 5 servers, 4 servers for local cluster, and each university contributes 1 server to the distributed cluster. There are 3 OpenNebula frontends in high availability. The distributed cluster allows us to replicate data and hot migration of virtual machines within universities. Current status and next steps. All 4 clusters are now active. We are being trained by OpenNebula. Next step is load testing and adjustments. After testing, project close phase 1. 4 functional backends, 1 of them distributed. Next milestones. For production environment, we need a backup system and consolidate the services. We need planning the grow up with new members and new hardware. Phase 2 requires dedicated domains, dedicated name servers, and load balancers. Now we have 3 domains, 3 name servers, and 3 routers. And for now, this is all. Thank you.
Thank you so much, Eduardo, for your presentation. So now let's introduce Stefan Kooman from BIT.NL.
Okay, today I got the honor to talk about the 2 software projects I care most about, which are OpenNebula and CEPH. So thank you, OpenNebula, for having me yet another year at the OpenNebula Con. So what are we going to cover today? Well, a little bit about me, a little bit more about BIT, the company I work for. Have a look at how the infrastructure looks like at BIT. We'll skip a few parts as how we use and why we use CEPH and OpenNebula at BIT. I've talked about that last year, so I would like to refer you to the presentation I gave last year. And then we skip to, hopefully, the most interesting part of the presentation, when CEPH makes sense to use and when better not to use CEPH. So who am I? I'm Stefan Kooman. I'm a sysadmin for over 2 decades, of which 13 has been spent at BIT. My main interests are distributed storage, virtualization, and networking. So BIT is a business-to-business internet provider, providing internet service, is a managed service provider and data center. Reliability and quality are the keywords. We own 3 data centers, and we use OpenNebula and CEPH in each of them, as we'll see on the next slide. So a short overview of our infrastructure, skipping over some details like core networking, DVDM. So we are connected to a couple of internet exchanges like M6, DACX, and LEX 36. We're in a BGP EVPN network, spine leaf, and have a dedicated storage network running IPv6 only. And like I said, in all of those data centers, we were in CEPH and OpenNebula. We gained most of our experience with CEPH and OpenNebula using 3 data centers, but recently acquired dual data center setups with CEPH in stretch mode as well. So like I said before, if you want to know more about our specific setup and reasons why we chose CEPH and OpenNebula, I want you to point you to this presentation I gave last year. So when does it make sense to use CEPH? Well, if you want to scale horizontally, you need to scale, or you just don't know how the future looks like and want to be sure that you have a resilient solution that you can rely on. If you want to have like freedom of choice in the kind of hardware you want to use and where you want to buy it from, and then you can use like all the way up from Raspberry Pis to high-end storage servers. You can have freedom of choice in the amount of redundancy you want in your storage network. So you can choose the number of replicas, 3 or 5, use erasure coding, or both if it makes sense. So basically you can fit Ceph to your needs. You tell Ceph how your infrastructure looks like and define a placement policy that reflects that. So you can use 3 data centers, dual data centers, single data centers. You have a bunch of racks or a couple of nodes. It's all fine. Just tell Ceph what you want to use. And basically, Ceph is a one-stop shop for all your storage requirements. Besides the native storage interfaces Ceph provides, like RBD, you can make it into a NAS or a SAN and even use it in Kubernetes environments. It comes with batteries included. It has advanced storage features like RBD mirroring, especially useful in disaster scenarios or if you want to do migrations. S3 comes with multi-site support, so you can build a resilient S3 solution as well. Storage steering is possible. You can use HDD, SSD, NVMe, or other types of storage. And when you use S3, you can even do that dynamically using policies. CEPHFS, the shared file system of Ceph, has mirroring capabilities as well, using snapshots. So you can also use that to use for disaster recovery. And in the future, you will even be able to do cross-cluster live storage migrations that can help you in load balance clusters and performance improvements, and have instant recovery of virtual machines in case you need it from an S3 backend. So like I said, you got freedom in the way you can deploy Ceph. You can choose OS packages all the way up to as code infrastructure. So there should be something out there for Unix Greybeards up to Ceph and cloud native hipsters using Kubernetes and Rook. Personally, I think Ceph ADM strikes a middle ground here. It uses containers and an orchestration, but does not pull in complexities of Kubernetes. And if you don't like what is out there, you can use custom deployment methods, write your own. When you have no single point of failure, it allows you to do advanced stuff. It allows you to completely reprovision your cluster. You can physically migrate your cluster from one data center to another, change failure domain policies, move around hardware, change the storage backend. It doesn't matter, all without downtime. And it's really hard to overstate the importance, because especially when you're running a storage cluster that needs to be up and running for 24/7, downtime is not an option. And it's really useful to be able to do maintenance and changes during the cluster lifetime. So a slide about when hyper-converged infrastructure makes sense or not. Well, like always, it depends. It generally makes sense for smallish clusters like 3-node clusters. It might also make sense when the storage requirements scale linearly with the compute requirements. It comes with some drawbacks though. If you need to reboot a hypervisor, then you will also have a degraded cluster. And especially when you have smaller clusters like 3-node setups, you might have some performance imbalance, which might to a certain extent be mitigated by the new primary balancer of Ceph. So dedicated storage clusters on the other hand can be be purpose-built. You can pick the right hardware for the job, pick the right CPU, kind of, so you can really tailor it to your needs. It can be independently managed. That's useful for system administrators. When you want to do a software upgrade or a storage upgrade, OS upgrade or not, you can do that independently from your hypervisor infrastructure. And you might get a more consistent performance because you're only running one workload instead of two. You might tell me, yeah, that's nice, but Ceph is hard, it's complicated, it's difficult to understand. While Ceph is certainly complex, I don't deny that. It has seen a lot of improvements along the way. In the past 7 years, we are running Ceph in production. There have been a lot of improvements. Too many to fit on the slide, but still, I put a few on them. So what stands out are upmaps. Upmaps makes the life of the admin easier. You can have obtain a higher effective usage capacity of your cluster. It helps you in doing maintenance, and some tools deserve a mention here, like PG Remapper and upmap and rewrap. They're just pure gold in managing big Ceph changes, all made possible by upmaps. Nowadays, you don't have to think too hard if you pick the right amount of PGs, because you can scale them up, you can scale them down, and Ceph can also do that automatically for you. So there have been a lot of stability improvements in MDS. Snapshot and multi-MDS are stable now. And Ceph ADM makes deployment really easy. Together with the dashboard, it's really a breeze to use. You can literally configure your cluster from your mouse in the dashboard. It's really awesome, and it's really fast as well. Ceph comes with metrics and logs, events, alerting out of the box, and that's really helpful in troubleshooting performance issues. You should just see how your cluster is performing and get alerted when something goes wrong. And finally, the documentation has improved a lot over the years and is getting better every day. If you still think Ceph is too hard for you to handle on your own, well, there's a lot of different options there, and you can pick the support model you need. So there's the Ceph user community you can go to. There are dedicated Ceph companies doing consultancy for Ceph. There's dedicated hardware that comes with support. There are enterprise Ceph storage solutions out there. There's custom Ceph software for deployment that comes with support as well. And well, you can always rent Ceph as a service like we provide, or ask your managed service provider if they can manage Ceph for you. So when better not to use Ceph? Well, if you need the performance, need all your performance out of the storage devices you use, so no overhead. If you use HDD, it might be quite okay, but if you use SSD or NVMe, you will never come close to the native performance of those devices. So if you need it, then Ceph is not for you. When your applications are single-threaded, latency sensitive, and better than basically the network with Ceph overhead on top can provide you, then it might be better not to use Ceph and look for an alternative. I would like to point you to this presentation I put online, which is really informative. And yeah, we will talk about when better not to use Ceph. So that was all for me. So thanks OpenNebula for having me another year, and thank you for listening.